All right, let's get started with 6-8 binomial theorem. So we're going to put into place Pascal's triangle, use the binomial theorem. So two objectives today: Pascal's triangle, use the binomial theorem. So three vocabulary phrases we're going to want to use, obviously Pascal's triangle and binomial theorem, and then expand. And expand is something that you should already be familiar with, expanding x plus 2 squared, things like that. All right, so we're going to talk about that more in a second. All right, let's start with the skills check here. So here's what I was talking about with expansion. Let's expand x plus 2 squared. Remember, the answer to this is not x squared plus 4. You need to FOIL this, all right? So same with these. We're going to use the box method on these. So take your time, work all the way through them. And then just a little review from last class on combinations. Make sure you can use these on your calculator. All right, here we go. Binomial expansion and Pascal's triangle. Okay, so learn to multiply binomials using the FOIL method and the distributive property. Okay, if you're raising a single binomial to a power, you have another option for finding the product. All right, so single binomial, so a plus b to any power. So when we're going to expand, let's look at some patterns. If we go a plus b squared, we FOIL a plus b times a plus b, and we get a squared plus 2ab plus b squared. If we did a plus b cubed and we FOILed all these together, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, so what we want to look at first is look at the coefficients. In front of the a squared, there's a 1. In front of the ab, there's a 2. And then in front of the b squared, there would be a 1 again. All right, let me get my pen going here. So I'm just going to write those down. 1, 2, 1. Let's look at the coefficients here. That's a 1, then a 3, and a 1. So 1, 3, 3, 1. This should look fairly familiar. We did something with this the other day. This is part of Pascal's triangle, right? So remember, we did all the way down to row 7. You should have these in your notes from the other day in class. All right, so guess what would happen if you did a plus b to the 4th? The coefficients would be 1, 4, 6, 4, and 1. All right, so notice that each set of coefficients matches a row of Pascal's triangle below. Pascal's triangle is a triangular array of numbers formed by first lining, etc. It tells you how to do it. We've gone over how to set this up. Next row would be 1 and 5 and 10 and 10 and 5 and 1. All right. So we have in here, so each row of Pascal's triangle contains coefficients for the expansion of a plus b to the n. For example, when n is 6, right? So if you're expanding to the 6th power, you can find the coefficients for a plus b to the 6th in the row that begins 1, then 6, then 15. All right? So if we did a plus b to the 15th, we would find the row that was 1, and then 15, and then so on and so on. All right? Now, we're going to learn later on a method where you don't have to write out the triangle that far down, okay? But that's how the coefficients would work. So let's use Pascal's triangle to expand a plus b to the 6th. All right, so we've got our triangle. So we're looking for the row that starts with a 1 and then a 6. So we're almost there. 1 and then 5 and then 10 and then 10 and then 5 and then 1. And one more. 1, 6, 15, 20, 15, 6, and 1. All right, so let's see what we've got here. We've got 1, a to the 6th, and then we've got plus 6. Guess what the a's are going to be? If you said a to the 5th, you are exactly right. And then what about the b's? Now we start counting them up. B to the 1st. Next coefficient is 15, so plus 15. What happens to our a's? We've got 1 less, a to the 4th, and then b to the 2nd. Now we're counting up. Plus 20, a to the 3rd, b to the 3rd, plus 15, a to the 2nd, b to the 4th, plus, almost home, 6, a to the 1st, b to the 5th, and then lastly, plus 1, a to the 0, don't have to write that, b to the 6th. All right, so that's expanded all the way out. You've got yourself your expansion using Pascal's triangle. All right, you're up. See if you can go 2 more rows. Go down to a plus b to the 8th. See if you can figure that all the way out. Lots of terms. Be consistent. Work it all the way through. Okay. So now what happens if you don't have the number 1 in here, like 1a and 1b? Okay. Still going to work. Okay, we're just going to have to be very careful with our parentheses. So x minus 2 cubed. So let's look at our row again. We want the 1, 3, 3, 1 row. So here's our coefficients. We're going to say 1 x negative 2 plus 3 x negative 2. Now I know I'm skipping the powers. We're going to come back to that in just a second. Plus 3 x negative 2 plus 1 x negative 2. And so here's what we're going to do. Remember that the x's start with 3 and go down. So 3, then x to the second, then x to the first, then x to the 0, which would just turn into 1. Negative 2 starts at negative 2 to the 0 and counts up. Negative 2 to the first here, then to the second, and then to the third. If you notice, if you add the powers from each term, they should add up to 3. So 1 plus 2 is 3. 2 plus 1 is 3. All right, so let's simplify this. 1x to the cube, negative 2 to the 0, just turns into x cubed. Negative 2 times 3 is negative 6x squared. Negative 2 squared is 4. 4 times 3 is 12, so plus 12x. And then negative 2 to the third is negative 8. And then times 1, x to the 0 is 1, times 1 is still negative 8. So this would be your expansion of x minus 2 cubed. All right, you're up. X minus 2, fourth. Down to the next row. All right, second objective today, binomial theorem. What do we do if we have a huge expansion? And what do we do if we just want a certain piece? All right, so we've kind of already figured this out. Here's our formula, okay? So you'll notice the a to the n minus 1, these count down, and then the b's count up. But now here's a new formula here. NC0, NC1, NC2. What the heck is going on there, okay? What that is if you notice from the skills check, if we go back real quick, all the way to the skills check, your answers here, where are you? There you go. Your answers to 5, 6, 7, 8, and 9 should have looked like a row from Pascal's triangle. Okay, it should have looked like row with 1 and then 5. Okay, 5, 10, 10, 5, 1. So let's take a look here at this formula again. All right, so when we start NC0, I'm going to use the number 5 just for n. 5C0. Remember our formula, 5 factorial over 5 minus 0 is 5 factorial, and then the second number is 0 factorial. Okay, so we have 5 factorial over 5 factorial. Remember that 0 factorial is just 1, so this cancels out and is 1. What is 5C1? That's 5 factorial. 5 minus 1 is 4, and then 1 factorial. So this is going to be 5, 4, 3, 2, 1 on top. But then what happens to the bottom? 4, 3, 2, 1. Because of this 4 factorial. Those would all cancel out, and we're left with 5. So this row is going to start matching up with the row of Pascal's triangle. Okay, so if we didn't want to go to like the 97th row, okay, because that would be a lot of Pascal triangling, okay, we can use this formula instead. So this first number is going to be what number do we want to expand to, and then this number will be what number in the expansion are we. Okay, 0 would be the first one, 1 would be the second one. If that's confusing, let's see if we can do this with some numbers here. We want to use this plus h to the fourth, expand this using the graphing calculator. All right, so let's set this up. I want to know 4C0, I want to know 4C1, 4C2, 4C3, and 4C4. Okay, all of the 4. So to the graphing calculator we go. And actually, let me get off of that. Okay, we actually know what 4C0 should be. That should just be 1. And 4C1 should be 4. This is going to be 1 and 4 on the other end. Okay, so what's 4C2? We can use our graphing calculator for that. Remember how we do this? We're going to say 4, then math, probability, NCR, that's number 3, and then 2, and we get 6. All right, so we've got 1, 4, 6, 4, 1. All right, so we're going to use that in our formula. We've got 1 g to the 4th h to the 0 plus next number 4 g to the 3rd h to the 1st plus 6 g to the 2nd h to the 2nd plus 4 g to the 1st h to the 3rd plus 1 g to the 0 h to the 4th. Just to clean that up, we're going to have g to the 4th plus 4 g to the 3rd h to the 1st plus 6 g squared h squared plus 4 gh cubed plus h to the 4th. All right, give that a shot yourself. 3a and 3b. Okay, use the binomial theorem, use the calculator. Okay, last one we're going to do here. So we're going to put binomial theorem and some probability together. So let's read through this here. You use the binomial theorem to solve probability problems. Suppose an event has a probability of success p. All right, so like this woman here, Dawn Staley of the WNBA, she makes 90% of her free throws. So P would be 0.9, okay? She's successful 90% of the time. Okay, she has a probability of failure Q. So in this case, Q would be 10%. Q would be 0.1. Each term in the expansion of P plus Q to the n represents a probability. For example, 10C2 P to the 8th Q to the 2nd, okay, could be confusing, let's work through this, represents the probability of 8 successes and 10 trials. Okay, so what we're going to do here is we're going to say, okay, what happens if we have 10 trials? Okay, we're going to miss twice. So the second number in the C, okay, is going to be how many failures you have. Then you're going to go probability of success to the how many times you want success power, probability of failure to the how many times you're going to fail power. All right, so let's walk through this using an example. Okay, so let's see what the probability is that Dawn will make exactly 6 out of 10 free throws. So we're going to say 10C. How many is she going to miss? If she makes 6, she's going to miss 4. Okay, the probability is 0.9 that she makes it. How many is she making? She's making 6 of them. Probability she misses, 0.1. How many does she miss? She misses 4. Okay, all right, so let's go to the calculator. 10C4. All right, so 210. Let's see what that times 0.9 to the, so we'll use the caret key here, 6th power, and then times 0.1 to the 4th power. Answer is 0.0111%. So that is a 1, what was it? 0.12% chance that she makes exactly 6, okay? So that seems awfully low, okay? But think about this. She's going to make 9 out of 10, right, if she hits her average. So 6 out of 10 would be way off for Dawn, okay? So not a great chance that that happens, okay? There's going to be a much higher chance that she makes exactly 9, or exactly 10, or exactly 8, okay? Exactly 6 of them would be a really, really unexpected event for Dawn if she's making 90% of the time. Okay, all right. See if you can figure out what the probability she makes exactly 9 and then exactly 10. Do that and you are home free. That'll do it. Any questions, make sure we're asking them in class next time, and good luck.